squares and square roots. So this video I'll explain you complete information about squares and square roots. Especially this is for class 8 students ICSE board. So before that, in this topic as well as other topics from the maths and other subjects, I'll show you website here. You can see the link in description below also. Now if you go through this, you'll find out all the subjects, chapter wise, topic wise, all the model papers including question banks also are available for free. So you can download and subscribe this channel because we'll upload only the videos which are related to the education. At the same time, it's very helpful for students. Fine, we'll start the topic now. Squares and square roots. First, we will see what is a square. So, square of a number. Square of a number. So, the square of a number is that the number raised to the power 2. So, the number raised to the power 2. So, that means, for example, if I take number 2, now square of 2, square of 2 is, that is 2 to the power 2, so that is equal to 4. That means 2 into 2. Now square of 9, so that is 9 is raised to the power 2, so that means 9 into 9, the same number you need to multiply. 9 nines are 81, so 81 is the square of 9. Similarly, we can see the decimal numbers. For example, square of decimals as well as fractions. For example, the square of 3 by 7, that means 3 by 7 is raised to the power 2. Okay, 3 by 7 into 3 by 7. So 3 3 is a 9 and 7 7 is a 49. Already we have seen some clear information in exponents and powers, right? So how to multiply. So in this, okay, the square of decimal I am taking. Now 0.3. Square of 0.3, 0.3 whole square. Because to the raised to the power 2. So 0.3 into 0.3. That is 0.09. So already we know about this in decimals topic, because after point there is only one digit here. After point is one digit, so finally in the result after point there should be two decimals, 1 plus 1. This is the square of a number. What is perfect square? What is perfect square? A natural number is called a perfect square if it is a square of some natural number. So the number should be square of some natural number. Now we have 1 square is equal to 1, and 2 square is 4, 3 square is equal to 9, 4 square is equal to 16. So in this, each of these numbers, that is 1, this 1, 4, 9, 16. So these are all perfect squares. So 1, 4, 9, 16. Similarly, you can say a 5 square is 25, 6 square is 36. So these are all the perfect square. So we can define like that. A natural number is called a perfect square if it is the square of some other natural number. So test for number to be perfect square. So how we can test? Now this is a simple small numbers, we know it, 1, 9, 16, 25, 36, so on. But if any big number is given, how to test which is a perfect square or not? So how to do testing? Now for example, I have given 7056. Now this number I need to test whether it is perfect square or not. That means number is multiplied with same number, we should get 7056. Okay, for this we'll apply the prime factorization method. So product of pairs. So we can write prime factorization method that your, if you know, okay, otherwise just once again listen here. 7056. We should divide with this only prime numbers. Okay, the prime numbers are primes 2, 3, 5, 7, 11. So with the product of primes, we should write this 7056. Now first prime number is 2 because 2 divisible. Then that is 2 3 is 6, carry 10, 5, 2 to the 4, 8. Again we can divide with 2 table. 1, 7, 6, 4. So how to do prime factorization? If you don't know, you can see other videos also is there. Now this is the method to find out the prime factorization. With the prime numbers we need to do division. Now again 2 table. 2 8 is 16, 1 carry, 8 is 16, 2. 441. Now come with the 3 table because 2 is not possible. 441. If you take 3, 1, 4, 7 because 7 21. 3 table. 3 4 is a 12, 27 is 9. Again this you can write 7, 7 is a 49, 7 1 is a 7. Now if you observe, these are all the prime numbers 2, 3, 7. So finally we can write 7056 is equals to 2 into 2 into 2 into 2. 4 times 2, again 3 into 3 into 7 into 7, right? So these all if you multiply at the same time you will get 7056. Now every number should be at least 2 times. 2, 2 into 2, 3 into 3, 7 into 7. So this is 2 square, again one more 2 square and 3 square and 7 square. So we can express it as the product of pairs of equal factors. Product of pairs of equal factors. Pair means 2, right? Pairs of equal products. So we can write like this. So that's what this 7056 is, a perfect square. So again in order to multiply, if you multiply again same answer will come. If we can write product of pairs of equal products, equal factors. So this equal factors. So 2, 3, 7 are the factors. So pairs of equal factors, if we can write that product, that number is nothing but is a perfect square. Let me take one more example. We'll check whether it's a perfect square or not. 9075. We need to verify this is perfect square or not. So what we should do? We should do prime factorization, product of prime factorization. 9075. So last it is a units place is 5. You can divide with 5 table directly also. Otherwise 3, 9 plus 7, 16, 16 plus 5, 21. So it's divisible by 3 table. 3, 3 is a 9, 0, 3 2 is a 6, 5 is a 15. 3 table is not possible now. Take 5, 5 6 is a 30, 2 9 was carrying, 2 5 is a 25. 5 table, 5 1 is a 5, 10 means 2, 1. This we can write 11, 11 is a 121. And 11 1 is 11. So finally 9075 I can write 3 into 5 into 5 into 11 into 11. So if you multiply these all numbers again you get 9075 only. If you observe, this is a 5 is a factor, there is a pair. two numbers 11, but is 3 is only one. So for this no pair, right? For this no pair, that means 9075 is a not perfect square. So it is not perfect square. So we cannot write that number. Full number is the product of pairs of equal factors. So 3 is a number, but no additional number for 3. Right? This is the way we can test the given number is a perfect square or not. So next we will see what is the square root and how to find out the square root. Square root of a given number using prime factorization method. So actually this is a, we need to find out square root only for perfect square number. So previously you have seen what's a perfect square. So any perfect square number is given, we can find out the square root for that. First we need to resolve the given number into prime factors. Okay, for example, find the square root of find the square root of 1764. 1764 I am taking. We need to find out the square root for this. So this 1764 is a perfect square only. So for that perfect square numbers only we use the prime factorization method to find out the square root. So we need to follow the steps. First step is resolve the given number into prime factors. First we have to make it as the division, resolve this the number into prime factors, then make the pairs of similar factors. Next we have to make it into similar factors. So 2 2 we should take, then we should need to multiply the that 1 number, that is we should do product. So let me explain with an example, it is clear for you. So 1764, this is a number, this is a perfect square number. First you need to write prime factors, product of prime factors. So that is a 2 is the first prime number. If you do division, 2 table, 2 8 is a 16, 1 carry, 1 6, again 8 2 is a, that means 2 8 82 is a 1764. Again 2 table, 2 4 is a 8, 2 4 is a 8, 2 1 is a 2. Right? Next we can take 3 table because it's divisible by 3. And 3 is the next prime number. That is 147. 3 table 49 is a, again 7 7 is a 49, 7 1 is a 7. So first we should resolve this number into prime factors. Fine. So we need to write first. So 1764 is equals to 2 into 2 into 3 into 3 into 7 into 7. Next is similar factors. Make the pairs of similar factors. So yeah, we made it. 3 3 2 2 we should take. That is, this is 2, 3 2 times, 7 2 times. Then final step is product. That means the product of prime factors, chosen one out of every pair. One out of every pair you have to choose. So generally you can write 2 square into, this is 3 square into 7 square. So 2 out of pair, 2 on a number I am taking. Next to 3 into 3, one number. 7 into 7, 1 7. So overall square, single square you can write. Let us give the square root of the given number. If you multiply 2 3 is a 6, at the same time 6 7 is a 42. So 42 whole square. Therefore square root of 1764, this is the square root symbol, is equals to 42. So third step is the product of prime factors, chosen one out of every pair, give the square root of the given number. Right? Let us check with one more example. Okay, whenever they will give the perfect square number only, we need to use this prime factorization method. See one question. Find the smallest number by which 720 should be multiplied. So 720 is a number. 720 is not perfect square. But question is, what is the smallest number by which 720 should be multiplied to get the perfect square? So what should multiply? What should multiply to 720 to get a perfect square? And what is the perfect square number? Then find the square root also, you'll find out. What is the smallest number should be multiplied to 720? Now 720, you start with prime factorization process first. 2 table, 2 360s, 2 180 and 2 90s. Same 2 table 45. Again 3. 3 is possible means you can take 3. 3 15s are 45. Again 3 table 3 5s are 15. 5 ones are 5. So finally 720 I can write as 2 into 2. All numbers into 2 into 2. 2 4 times, again into 3 into 3 into 5. Fine. So here if you see the pair 1 1 number 2 times, 2 into 2, 2 into 2, 3 into 3. So one extra 5 is there. That means one more 5 if I multiply, then this becomes perfect square. So what is the smallest number should be multiplied? So 5 is the smallest number we need to multiply. Then this, so we should multiply the given number by 5 to get the perfect square. That is 720 into 5. If you multiply with 5, this becomes perfect square. That is 3600. So 3600 is the perfect square. Therefore, square root of 3600 is equals to, so because of these two 2's, 1 2 I can take, and one more 2, another 3. Only 5 extra, 1 5 is multiplied, so another 5. Because according to the third property, third rule, we should take 1 out of every pair. Fine, here out of 2, 1 2 is taken, and out of 2 1, out of 3, one number is multiplied. So 3600 is done. 2 to the 4, 4 3 is a 12, 12 5 is 60. So 60 is the square root of 3600. So let me explain one more question similar using the prime factorization method only. Find the smallest number. Find the smallest number by which 6000 should be divided. So previous problem is what should you multiply? Now this is divided to get a perfect square. And we'll find out what is the perfect square number to obtain and find the square root of that number also. Let us see the square root of that number also again. So as per question, 6000 is a given number. So this is not perfect square. No, but what we need to divide with this 6000, what is the smallest number we should divide to make it perfect square. So same rule will apply. Take 6000, do first of all prime factorization. 2 table, 2 3000, 2 1500, again 2 table 750, 2 table 375. So now it's not divisible by 2. Next 3, 3 ones are 3, 3 twos are 6, and 15 is 3 5s. Now again 5 table, 5 twos are 10, 25, 5 5s are 25, 5 ones are 5. So finally the given number is 6000. Just write as product that is 2 into 2 into 2 into 2. Again 3 into 5 into 5 into 5. So clearly in the product of prime factors there are three pairs of equal, right? So just you see the three pairs of equal. This is one pair and this is one pair and this is also one pair. Next remaining is 3 and 5. So these 3 and 5 we need to remove. That means we can write 3 into 5 together is 15. So 2 into 2, this is one set, and 2 into 2 is one set, and one more is 5 into 5 into these 3 5s and 15. So if you, this 15 should be removed. That means 15 is actually multiplied. So if you divide this 15, 6000 if you divide by 15, then this we can cancel. So we must divide the given number by 3 into 5, that is 15. So let us check now. 6000 divided by 15. So if you do 6000 divided by 15, you will get 400. So 400 is the perfect square. So then 400 is equals to, the remaining part is 2 into 2 into 5. Square root of 400 is, so that is 20. Because each pair, the remaining is, instead of this 2, 1 2, instead of this 2, 1 2, instead of these 2 5s, 1 5. So this is the smallest number you should divide, means 15 you should divide to get the perfect square number. So this is the way we can solve. The same time, yeah, whatever you should multiply or divide. Multiply means that extra we need to multiply, which is required. Division also, that which is extra, but that same number only you have to divide. Apart from the pair of equal factors. One more question I'll write here. This little different. That is, find the least square number. Find the least square number divisible by each one of 12, 15 and 20. This is the question. Find the least square number divisible by each one of the 12, 15 and 20. So least number divisible by each one of 12, 15, 20 is nothing but LCM, right? First you need to find out LCM of this. LCM of 12, 15, 20. So least square number should divisible by each one of them. So let us first find out the LCM. Now 12, 15, 20. LCM is 2 table, 6, 15 and 10. 3, 15 and 10. Yeah, 5 it is. 3 table, 3 ones are 3 5s are 5. So in 5 table. So finally the LCM is 2 2s are 4, 4 3s are 12, 12 5 is 60. So 2 into 2 into 3 into 5. That is 60 is the LCM. By prime factorization 60 will get least square number they are asking. So again you have to do the prime factorization for 60 now. 2 into 30, 2 into 15, 3 5s are 50, 5 ones. So finally 60 I can write 2 into 2 into 3 into 5. So to make it perfect square it must be multiplied by 3 into 5. So 3 into 5 is 15. So extra 15 you need to multiply for this. Hence required number. So required number is equals to 60 into 50. That is 900. So that means it says the 900 is the least square number that is divisible by each one, 12, 15, 20. That means 900 we can divide by 12, 900 we can divide by 15, same 900 we can divide by 20 also. Least square number they asked. So perfect square is this. 60 is any number, but square number is 900. Okay, in the same question, least only number. If they ask only least number instead of square word, 60. So least square also means 900. So this is the way we can find out the numbers which is multiplied by some number or which is divisible by some number to get the perfect square. This is the procedure we can follow. So next we will see some properties of the square number. Properties of perfect squares. So I'll explain you 6 important properties regarding perfect square. So let us see one by one. First property is a square of an even number is always an even number. Square of an even number is always an even number. So any even number you take and apply the square, again you will get the even number only. So we'll see example. So for example, 2 is even. 2 is even, right? And square of the 2 is also even number. 8 is even number and 8 square 64. So is also even number. Next one. Square of an odd number is also always an odd number. Square of an odd number. Square of an odd number is always an odd number. So similarly you can take some example for odd number also. 3 is odd number. 3 is odd. Then 3 square 9. So is also odd number. Not only that, you can take 15. 15 is odd number. So 15 square, that is 15 into 15. 15 15s are 225 is also odd number. One more. The square of proper fraction is a proper fraction less than the given fraction. So for example, if you take any proper fraction, square of a proper fraction square of a proper fraction. So proper fraction is numerator is lesser than denominator, right? Square of a proper fraction is a proper fraction less than the given fraction. Is less than given fraction. So for example, I will tell you example is clear. Now for example, I'll take 1 by 3. So 1 by 3 is a proper fraction, but 1 by 3 square is 1 by 9, but 1 by 3 is, so 1 which is a taking, that means 1 by 3 must be greater, so 1 by 9 is less, so 1 by 9 is less than 1 by 3. So square of a proper fraction is always the less than the given fraction. any proper fraction you take. Now for example 2 by 5 is a proper fraction. Now 2 by 5 whole square is 4 by 25. So that answer, the square is less than 2 by 5. So other numbers means they are only more. Okay, previous example, if you take 15 square is 225. So 225 only is greater than 15. Okay, now 3 square is 9. So 9 only greater than 3. But when you come to proper fractions, the square only is less than the given proper fraction. That only it says. Fine. Now fourth one we come to the decimals. Similar like for proper fraction rule. That is, the square of a decimal fraction is less than 1, is smaller than the given decimal. The square of a decimal fraction less than 1. So less than 1, any decimal fraction if you take is smaller than the given fraction, a given decimal. Fine, let us see example. So you should take any one decimal number which is less than 1. That is 0.3. Now this is less than 1. So 0.23 square, that means whole square, is 0.09. So that 0.09 is actually square of 0.3, but that only is lesser than the given number. So proper fractions as well as decimal numbers which are less than 1 have the same rule. So that number itself is smaller than the given numbers, given proper fraction or given decimal. Next rule, property 5. This is a number ending in. This is important for any objective type, especially a number ending in 2, 3, 7 or 8. 2, 3, 7, 8 is never a perfect square. So you need not to check again, because if any number is ending in 2, 3, 7, 8, any one of this number is there in units place, they are not at all perfect squares. Okay, example 72. So 2 is in units place. 243, 3 in units place. 567 and 988. So the number which is ending with 2, 3, 7 or 8, it is never be a perfect square. So none of them is perfect squares. Not only these examples, you can take any example which is ending with 2, 3, 7, 8 in units place. So objective wise or in the ask for finding perfect square, directly you can guess it by seeing these digits. And one more rule also which is never be perfect square, that is a number ending in odd number of zeros. A number ending in an odd number of zeros. So there also is never be a perfect square. Is never be perfect square. So odd number of zeros, right? The example is if you take 80, 820. Only one zero. That is odd number. 25 is perfect square. But if I'll keep three zeros, so 25,000. So this is also not a perfect square. Any number you can take ending 49,000,000, 5 zeros. That is 49 lakhs. So that is not a perfect square because ending in an odd number of zeros. Okay, these are the six properties you can use to finding the perfect square and which is less or which is more for easy way. Next we see some interesting patterns in square of numbers. Some interesting patterns in a square number we'll see now. So actually I'll say you some important rules which are related to the square of numbers in some pattern formation. So around 7 simple topics I'll explain in this session now. For example, first one, if you see square of a number, all we have see just now. For example, 1 plus 3. So this is two are odd numbers. So sum of the first two odd numbers. Sum of first two odd numbers. Now if you add these two odd numbers, 1 plus 3, that is equals to 4. That is nothing but 2 square, right? So I can write like this. So I'm making some pattern now, just observe here. Now 1 plus 3 plus 5. So this is sum of the three first odd numbers. So sum of first three odd numbers. Now this is 1 plus 3 plus 5. That is equal to 3 square. So sum of the first three odd numbers is 3 square. That is nothing but equal to 9. So similarly, same pattern if you apply 1 plus 3 plus 5 plus 7. So this is sum of the first four odd numbers. So if you add these four odd numbers, that is nothing but equal to 4 square. So you can add this 9 plus 7, 16. So now we can generalize formula. So we have for every natural number n. So it's clearly can say sum of first n odd natural numbers. Then one pattern we can conclude like this: the sum of first n odd natural numbers is equals to n square. So need not to count again all the odd numbers. So based on this we can write example like this. Yeah. Now for example 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 is equals to dash. So need not to add. Now you see just how many odd natural numbers. 1, 2, 3, 4, 5, 6, 7. So that is nothing but 7 square. So even if you add all the sum, you'll get 49. So sum of the first n odd natural numbers is n square. So this is one of the pattern. Now we'll see one more. Now one okay, for second I'll write one pattern, observe here now first. For example, 4 square minus 3 square, that is 16 minus 9, that is equal to 7. So 7 I can write again 4 plus 3. So 5 square minus 4 square, that is I can write 25 minus 16, that is equal to 9. So that is nothing but again I can write 5 plus 4. Okay, similarly can you say 6 square minus 5 square, So that is 36 minus 25, because 5 square is 25, and 36 minus 25 is 11. So 11 I can write 6 plus 5. So like this pattern if you continue, okay, if we take 11 square minus 10 square, so that is 121 minus 100 equals to 21. That I can write again 11 plus 10. So apart from numbers, now we can general. Now I will generalize. For example, n plus 1 whole square minus n square. Now this we can write first number plus last number. So first one is n plus 1, second one is n. Now we can generalize this, n plus 1 plus n. So n plus 1 whole square minus n square is nothing but n plus 1 plus n. So this is a generalized form. So we can take in the place of n any number. Right, you can write 21 square minus 20 square also is nothing but 21 plus 10. That is 31. And let's see third, one more pattern. Third one. So third is related to the Pythagorean triplet. So I'll explain you first Pythagorean triplet. So Pythagorean triplet. Pythagoras is a great mathematician. So he did a Pythagoras theorem. So the Pythagoras theorem says in any right angle triangle, so a right angle triangle is one angle is 90 degrees. So in a right angle triangle, say ABC, so longest side is nothing but AC, that is hypotenuse. Now other two sides, hypotenuse, I am taking some small b, this takes small c, this takes small a. Then we can write b square is equals to a square plus c square. That is hypotenuse square is equals to sum of the squares of other two sides. Is actually Pythagoras theorem in right angle triangle. So if you take this is a 5. Now which numbers will satisfy this? For example, I am taking 5. This is 4 and it is 3. So 5 square is equals to 3 square plus 4 square. You check it now. 5 square is 25. 3 square is 9. 4 square is 16. 25 and 25. So 3 comma 4 comma 5 is a Pythagorean triplet. So for every natural number, now how we can make our own any triplets? This is only for one example. Generalize one formula for Pythagorean triplet. For every natural number m is greater than 1. If m is a number is greater than 1, then we have, so which three numbers will follow Pythagorean triplet? Now we can write that is 2m comma m square minus 1 comma m square plus 1. This is a Pythagorean triplet. So you can take any number in the place of m which is greater than 1. Okay, let m is equal to 3. Then 2 into 3, 3 square minus 1, 3 square plus 1. Yeah, 3 square it is. In the place of m, just I am keeping 3. So 6 comma 3 square is 9. 9 minus 1 is 8. 9 plus 1 is 10. So 6, 8, 10 is a Pythagorean, one of the Pythagorean triplet. You can check it is longest value square means hypotenuse square is equal to sum of the squares of other two sides. That is 6 square plus 8 square. If you simplify, you will get a equal in both sides. This is 100, 36 plus 64. 8 square. So 100 is equals to 100. Therefore 8, 6, 8, 10 is a Pythagorean triplet. Now this is a generalized formula. 2m comma m square minus 1 comma m square plus 1 is a Pythagorean triplet. In the place of m, whatever number else you can take, anything which is greater than 1, we'll make a Pythagorean triplet. One more pattern now. Here, between two consecutive squares, between two consecutive square numbers, say n square and n plus 1 whole square. So between two consecutive square numbers n square and n plus 1 whole square, there are 2n non-perfect squares. In between these two, there are 2n non-perfect squares. So consecutive I am taking here. This is consecutive means just side by side numbers. Consecutive square numbers. So between any two consecutive square numbers, there are 2n non-perfect squares. I'll give you an example. For example, 3 square and 3 plus 1 whole square. So in between these two, there are 2 into 3 non-perfect squares. 2 into 3 non-perfect squares. We'll check it now. 3 square is 9 and 3 plus 1 whole square is 4 square is 16. So in between 9 and 16 there are 2 into 3. So there are 6 non-perfect squares. Okay, 10, 11, 12, 13, 14, 15. Okay, these are all 6. Exactly came right. 6 non-perfect squares. In the place of n, we can take any value. Okay, or else if I take 5 square and 6 square, 5 square is 25, 6 square is 36. So 2 into 5, there are 10 non-perfect squares in between this. Next we'll see some 3 identities which is useful this exercise sums in this chapter. So using an identity, so 3 identities I'll use, just nothing but formulas. This is one is a plus b whole square, that is a square plus 2ab plus b square, right? And one more rule for identity is a minus b whole square. So a square minus 2ab plus b square. And one more rule for one more identity is a minus b into a plus b is a square minus b square. So these 3 identities, if you remember, we can solve some problems which are related to this in this formula. For example, 53 square we need to find out. So we can reduce into 50 plus 3 whole square. So using identities also we can find out the square. 50 plus 3 whole square. So 50 square plus 2 into 50 into 3 plus 3 square. 50 square is 2500 plus 2 into 50 into 3. 2 5 is 10, 10 3 is 30. So 300 plus 9. That is 2809. That is 53 whole square. Find similarly a minus b whole square. Okay, if they asked find out 96 whole square value. So which is near to 100. 100 minus 4 whole square. So according to this formula, a square minus 2ab plus b square, you need to write. That is 100 square minus 2 into 100 into 4 plus 4 square. 100 square is 10,000 minus 2 into 100 into 4, 800 plus 4 square is 16. So we'll subtract this and we'll add 16. So we'll get 9,216. So we can solve the squares, finding the squares using this identity also. This third identity, if you observe, now example, we need to find out 49 into 51. So here, to find a product of two consecutive odd or two consecutive even numbers, consecutive odd or consecutive even numbers only will apply. 30 into 32. So either consecutive odd or consecutive even. 49 plus into 51. That is 50 minus 1 into 50 plus 1 with same number opposite sign. So 50 square minus 1 square using a square minus b square formula. So 2500 minus 1 is 2499. Now 30 into 32 also similar. This is near to this 31. 31 minus 1 and 31 plus 1. So 31 square minus 1 square. 31 square is 961 minus 1, 960. So this is the finding of squares using these identities. Now up to here we have seen the finding the square root of a perfect square by using prime factorization method. So next I'll explain you and we'll discuss how to find out the square root of perfect square by using a division method. How to find square root of a perfect square by using division method. So division method is one of the very important method to find out the square root, and it is easy at the same time. It's a shortcut method apart from using the prime factorization. Okay, I'll explain you clearly this method now. So this now we will see only finding the square root of a perfect squares. So 841 is a perfect square, so it is a square of some number. So for that number we will see first of all how to find out the square root using this division method. Later on we will see decimal numbers and which are not perfect square also. We will see how to find out the division square root by using this division method. Now 841 is a given number. We need to find out the square root for this. Right. First, this number we need to convert into periods. Periods means, so every two digits I need to take one set from units place. The unit place is 1, next followed by 4. So 41 is one set. Next only 8 is left. So from right side means from the units place we need to take two digits as one period. So that is 841. So I'm going to do division method. Now 41 is one set. We can mark a line 41 and next 8 because only one number is left. So there is one period. Now in every division the down which is coming is a remainder and this right side place is a quotient. So this is a dividend and this is the left side is divisor. The first step is 8. So first period is 8. Now 8 is which perfect, near to which perfect number is this? We need to find out. So if you take 3 into 3 is 9. 2 into 2 is equals to 4. 1 into 1 is equal to 1. So in this number which is near perfect square, so it's nothing but 4. Okay, because 9 is more than 8. So next before number is 4. So that means we need to write 2 2s are 4. Same we should write left side as well as right side. Here if you keep 2, same 2. Don't take 2 4s 8 like this, not a normal division. We need to use only perfect squares. So square only should take. So 2 2 is a 4, right? Next, normal division, you need to subtract. So if you subtract this, 8 minus 4 is 4. Now next full period we should take down, that is 41. So after subtracting 8 minus 4, next period we should take down, that is 41. Next, the method is now 2 is in this place, means this divisor place, the value in units place should be double. So here only one number 2, so if you double this, it will become 4. So unit number you should add to this divisor, that means, so divisor itself only unit number here, only single number, so we need to add again 2 for that, that is 4. Now 4 is, now this is a tens place, now we need to check for units place now. So here and here should be same number again, the number is 441. Now in 4 is in tens place, next to one more number we need to check, that is 4 in tens place, 4 into dash, same number, like means 41 ones are, 42 twos are, same should come here and here, after side of the 4 at the same time side of the 2, because the squares it is. So 40 near until this 441 will come. Okay, if you do that, 41 ones are 41, 42 twos are 84. So if you keep on, if you write 49 nines are is 441. So you need to keep the same number here and here always. So 49 nines are 441. Now if you subtract, this is 0. Until you get 0 you have to do. Then whatever is the number in quotient place, that is the square root of 841. So here is number is 29. So square root of 841 is equals to 29. So if you're maybe not very much clear, so I'll explain you one more example. Let us see, 7056. So you need to remember the method first. 7056. So according to method, we need to take two numbers, one pair. That is 56 is one set, 70 one set. So 7056. So I'm going to find out square root of 7056. It's a perfect square using division method. Then take the period. That means from units place to 10 place 1, next to 0 to 70. So 70 and 56. So here 70 is the first number. So first period. 70 is near to which perfect square? 6 6 is 36, 7 7 is 49, and 8 8 is 64, and 9 9 is 81. It's more than that. So 8 8 is 64, because 9 9 is 81. It's coming more than that. So it will come more than 17 if you take 9 into 9. So in this place and here it should be same number. So 8 8 is 64, right? Now normal division, you can do subtraction. 70 minus 64 is 6. Then next period we should take down, that is 56. Now 656 is number. So what I said, now this number should be double. Units place, whatever units place should be double. So you only single digit. So if you make it double, that is 16. So if you double that, 16. So this should be double. Units place should be double. Now side of the 16, next one more. Now 16, always units place only we need to verify. So 116 next side, if you keep 2, if I'll keep 2, same 2 also should keep here. If I'll keep 3, means 163, means here also should keep 3 only should keep. So we need to check with right side. Now 16, that gap is there. So 161 ones are. 162 twos are. So same here and here. That is important. 163 into 3. 3 and 3 is and not taking different. 164 into 4. Now check which is near to this 656. 161 ones are 161. 162 twos are 4 and 6 twos are 12. So 324. It's not coming. But 164 fours are 656. This is 656 is coming. So you should keep 4. Same 4 should be here. So 164 fours are 656. If we subtract 0. Therefore, square root of 7056 is equals to 84. So finally you must write which the number in the place of quotient. It's clear, right? So this is 2 periods. Next one more example I'll explain it with taking 3 periods, means more than 4 digits. You'll get some more very clarified in these problems. So I'm taking a number 17,956. So find the square root of 17,956 is equal to dash. So division method, if you do, it's very easy. We'll finish fast. So whatever the method we asked, what you need to do. Now question is 17,956. From units place onwards, you should take pair, one pair. That is 56 is one set, 79, and next only 1 is there. So 1 itself is a period. So 1 is perfect square, means 1 only. So we can write directly 1 ones are 1 itself. Because same number also can come. Now if you subtract, this is 0. Next set is 79. So according to our method, this number should be double. Now here 1 right. So we should make into 2. Double means into 2. That becomes 2. Now this is 2. Then we need to check the number side. 2 and here also same numbers. Like it's 21 ones are, 22 twos are, 23 threes are. So it's almost near to 23 threes are. 23 threes are 69. Because 24 fours are, it's more than 79. Okay. If I'll take here and here should be same number. The place of divisor and quotient should be same in units place always. So 23 threes are 69. Because 24 fours are, it will be more than 79. No, 69 it is. So if we subtract, it is 10. Now take the next set, that is 56. Okay. Now here units place is 3. Now this units place 3 should add to tens number. Same extra, whatever unit number is there, extra one more number should add. That is 26. Because 3 I am adding extra. If you observe here, 23 and plus 3 is equal to 26. Clear, right? In this unit place, whatever number is there, once again add to this total number. That is nothing but units place only is double. So 26. Now 26, next number should be filled. 26 is just now you came 1 into 1 you keep. 26, 2 into 2. 26, 3 into 3. Same number should get. If you keep on, if you do 264 into 4. So you'll get the answer for exactly for 4. 264 4s are 1056. 0 if you subtract. Therefore, square root of 17,956 is equals to 134. So this is the actually division method we need to do, finding the square root, finding division method. So using this division methods, a few problems also I'll ask. I'll show you how the questions will come from based on this division method. Let's see question. Find the least number. Find the least number which must be subtracted from 7581 to obtain a perfect square. Find the least number. The one is the important thing is least number. It must be subtracted from 7581. So 7581 is a not perfect now up to now. But something if you subtract from this, then it will become perfect square. So what we need to subtract, that we have to find out. So just a normal division method only, we'll start the problem first. That is 7581. So with the division method only, we'll start the sum. Then we can see what we need to subtract. Now 81 is one set, 75 is one period. 2 we should take from right side. Now if you observe, this is 8 8 64, because 75 is near to 64, is a perfect square. Subtract this, it's 11. Take next pair, 81. Now this 8 becomes double, means that is nothing but 16. Now next place, this near is 1181. So 160, if you use calculation, 167 sevens are 1169. Now if you do subtract 12, so from extra 12 came, right? So from this what we can conclude, 87 square is less than 7581 by 12, because some extra 12 came here down. This extra 12 we need to subtract. So 87 square is not exactly equal to this, but 87 square is less than 7581 by 12. Therefore we can then we can subtract 7581 minus 12, that is 7569. Okay, now 7569 is a perfect square. So what is the least number, means that 12, how much extra is coming, same we should do. This extra whatever will come, that we need to subtract. So that is finding the least number which must be subtracted from the any number to obtain a perfect square. Okay, some questions are asked, what must be added. So I'll explain now. One more question. So what least number must be added? Two, 2945 to get perfect square. So here what we need to add. So 2945 also is not a perfect square, but some number if I add to this, we'll get a perfect square. Now procedure is same, but last little step will become different. 2945, you take a pair numbers 45 and 29. Fine. So 5 5s are 25. Subtract is 4. Next set is 45. This 5 becomes double is 10. Then 101 ones are 102 twos are. If you take 104 fours are 416. So if we subtract 29, now 29 extra came, but actually 54 square is less than 2945, that is less than 55 square. Okay, 2945 is less than 55 square. At the same time, that is greater than 54 square. But what must be added? Then you can take 55 square. So in almost this is nothing but 55 square. So 55 square is equals to, so 55 into 55, 3025. Erasing. So previous problem, what must be subtract means that directly that we can subtract, which is coming extra. That is what must be added means you should go for next perfect number. So 55 square. So required number to be added, that is 55 square is 3025. From this 2945 you subtract, that is equal to 80. Okay, if you subtract, now 80 if you add to the previous number, so the 80 extra came. Therefore square root of the result number, that means 2945 plus 80 is equal to 3025, is equal to 55 square. So square root of the result number is 55. So simple thing, only thing you remember here, now here you got 54, right? So it is equal to 55 square now. So if you want to 55 square, what we should add? So 55 square is 3025. So if you want to get 3025, what we need to add to 2945? So what we need to add to means just subtract both 80. 80 only we should add. Okay, what must be added? That is equal to 80. And same division method concept only. One more question, similar type. Find the greatest number of of 4 digits which is a perfect square. So find the greatest number of 4 digits which is a perfect square. So greatest number of 4 digits. Actually 4 digit greatest number of 4 digit is 4 nines. But 4 nines is not a perfect square. But less than 9999 there is some number which is a perfect square that we need to find out. So method is same, we can start same like division method. Generally take the greatest of 4 digit number and start doing division method. Now this is 9 nines 81 18. If you take the next set 99. Okay, this 9 becomes double is 18. This is double. And 189 nines are. So just solve now. 189 nines are 1701. Fine, if you subtract, we got 198. That means clearly saying that 198 if extra is there, that if I subtract from 4 nines, we'll get the greatest number. So required number is nothing but 9099 is not perfect square, but from that this extra 198 if I subtract, then we'll get the uh, greatest 4 digit number perfect square. So if you subtract, that is 9801. Okay, if you do division method, again same, we'll get some perfect number. So 9801 is the perfect square which is greatest 4 digit number. Okay, similarly we'll get the questions, find the least number also, least number of 6 digits, 4 digits, like that. I'll write one last question here in this from find the least number of 6 digits which is perfect square. Find the least number of 6 digits. So least number of 6 digits is nothing but after 5 zeros. 1 2 3 4 5. This is the least number of 6 digits. Now let's find the square root of this. Method is same, from 2 to will take scheme 10. So 3 3 is a 9. Subtraction is 1. Next to 2 zeros you take as is. 3 becomes 9. Okay, sorry, 3 if you double it's 6. We should double it into 2, 6. Then 61 ones are 62 twos are, because 61 ones are 61. Then if you subtract, that is 39. Take next period, that is 3 2 zeros. Now this units place is 1, so extra one more 1 I should add to this, that becomes 62. Okay, there is nothing but 61 plus that 1, whatever units place again you will add, that is equal to 62. Now next place, that is 626 6 are 626 6 are 3756. So just subtract 144. So least number of 6 digits which is a perfect square, they said. Now what we got, 316 we have. So 316 only, even for 316 also something we need to subtract. So that means next number is 317 square. Therefore the required number which is a 6 digit perfect square is nothing but 317 whole square. If you multiply 317 into 317, 100,489. So quotient place we need to observe. So your quotient place is 316, but 316 also some extra number. That means 316 is less than 6 digits. So 6 digits least number. Next number is 317 square. So 1 lakh 489 is the least number of 6 digits which is a perfect square. Fine. This is the, whenever the numbers are given, integers, natural numbers, use this method. Now next topic we'll see how to find the square root of numbers in decimal form. Okay, in decimal form also we'll see how to find out the square root. Square root of numbers in decimal form. So if a number is in decimal form, we'll find out the square root using division method only. So first of all, if any number is given, we have to make the decimal places even. So decimal places should be even. Okay, for example, take one question now, 32.49. So I need to find out this square root of 32.49 because if it's in decimal form. Now after point there should be even digits. In case if it is odd digit, we'll add 0. Okay, then we can make it and find out the square root. So let us find out. So same method will apply, same as it is. We'll take the 2 from right side. So we'll mark it 49 and 32. So now point is here. So first of all, this 32, the perfect square which is near to perfect square is 5. 5 5 is a 25. Because 6 6 is a 36. It will more than that. So 5 5 is a 25. If you subtract 7. Now whenever you take the set, whenever you take the period, soon after point, then you also need to keep the point here first. Okay, I drag the number after point, I took this period down. So immediately keep the point in the place of quotient soon after the number. Then method is same as it is. Now 5, this is becomes double is 10. Now next place and here same place should be same. So 101 ones are 102 twos are like that. 107 sevens are 749. It will come clearly. So 5.7. So square root of 32.49 is equals to 5.7. Okay. After point there should be even digits. There is one important rule in this. So I'll explain some other examples. Let us see one more example. Find the square root of find square root of 79.21. So this value we need to find out. So here 72.9 79.21. Now take a pair 21 because after point it is even number of digits. So there are 2 digits after point. 2 is an even number. So 79.21. Now 79. 7 7s are 49. 8 8s are 64. Okay, in 8 table. Because 9 9s are 81. 9 9s are 81, it will be more than 79. If you subtract 15. Now whenever I'm taking 21 down. So the 21 is soon after point. So you also keep the point here. Now 8 becomes 16. Now we check 16 next place. 161 ones are 162 are so 169 nines are is 1521. If it is perfect square, exactly you'll get the 0 in the denominator place, in the remainder place finally. So that is, so answer is 8.9. Okay, one more example. Evaluate. So find or evaluate, everything is same. Evaluate square root of 0.4225. So all number of digits after point there are 4. So 4 is a even number. Now I'm taking 0.4225. Fine. So in this case, method is same. 2 2 we need to take. Then here only 0. So 0 table itself. 0 0 is a 0 only should keep. Now I am taking this 42 down. So 42 is after point. So we need to keep the point. Then so 0 if double also 0 only. Next we can take, so 42, okay, 0.4225. Next if we take 42 is near to perfect square is 6. Okay, 6 6 are 36. Because 7 7 is 49, right? It's more than 42. Now 42 minus 36. 36. So take next set 25. So 6 becomes double is 12. So after 12 again one more number. Now 125 5 is 625 0. So that is 0.65 is the square root of 0.4225. So only the important thing is whenever the number of digits after decimal, if there are odd numbers, we need to keep extra 0. But here every question is odd number. Number of digits after decimal is even number. Right? Now if it is a perfect square, we have seen till now how to find out the square root if it is a perfect square number. So next topic I'll explain you. Now I'll explain finding the square root of number which are not perfect squares. Square root of number which are not perfect square. So if it is not perfect square, then how to find out the square root? That we will see some decimal numbers. So decimal numbers which are not perfect squares. So how to find out the square root? So let me take one question first. Find the value of square root of 24.789. So find this value correct to two places of decimal. Fine, we need to find out the square root of 24.789 correct to two places of decimals. So here important notice, if they asked correct to two places of decimal, now we shall find it up to three places of decimal and then round it off up to two decimal places only. So up to three decimal places we need to find out. So if you want to three decimal places after decimal, there should be six places we need to take in the question. So let me explain. So we are using this, so using division method only. 24 point 24.789 is the given question. So we need to correct to actually up to three places of decimal we have to find out first. So three places means extra three zeros I need to take, because if I want two places of decimals there should be four digits after point. But when question itself they asked through two places of decimal, so we need to take up to three decimal places, that means six digits. After point there should be six digits. So answer will come in three decimal places, three places of decimal. So we'll round it off to two decimal places. Now let us take 2 one period 0 0 90 78 and here 24. Right? Now 24 is a perfect square near to is 4. 4 4s are 16 because 5 5 is a 25. It's more than 24. If you subtract, that is 8. Now next set is 78. Take 78 down. So because I'm taking period after point, so you keep the point. And now this 4 is double 8. Next 81 ones are 82 twos are, like that you need to take second place. You should, and here and should be same places. Now 89 nines are, because big number, 89 nines are, we'll get 801. 878 minus 801, that is 77. Next to 90, take the set down 90. So here 89, so units place is 9. Now this units place again we need to add for 89 itself. So that is 89 again plus 9. that is 98. Okay. Now after 98 you should check units place in both places. That's 98, again 981 ones are, or 982 twos are, like that we need to check up to 7790 will come. So now that is 987 sevens are, 987 sevens are 6909. So I am using calculations here. Now subtract 881. Yeah, carry 10 minus 198. Now, so one more set, two zeros. Keep two zeros here. So now this is 987. So in this 987, units place is 7, 7 I need to add. That means 987, whatever units place we need to add again. That is 1499. So 994. So now we write as it is 994. Now next place, and next place you check it now. Now that is 994 1 ones are 994 8 eights are. It'll be near to this. 8s are. This is how much? 79584. Yeah, if you calculate, subtract. So direct I'm using calculations here. 8516. You can verify if you subtract. Now need not to take now. So finally we got here 4.978. So answer is equals to 4.978. So we have three place of decimal, but the question is up to two place of decimal. So third place you have to round off. So round off means if the third place, third after point, third place is more than 5, 5 and more we can add to the previous number. So previous is 7, 7 becomes 8. Now this third place, if it is more than 5, we'll add 1 plus 1 to the previous number. That is 4.98. Is the square root of 24.789, correct to two places of decimal. Fine, I'll explain you one more question. Evaluate square root of 0.8, correct up to two places of decimal. Two places of decimal. So we can take two places of decimals. After point there should be 6 digits, because we need to correct up to 3 places first. So 0.8 one digit is given. Now another 5 we need to keep. 0. Now this is it. Up to 3 places of decimal we have to find out first. Mark it 2, 2, 2 and 0. So already it's 0 point. So you also can start with point. Instead of taking this directly, you can take second set. That is 8 eights. Same will come 64, because 9 nines is more than that. In case before point, if it is 0 itself, you also start with point and can take the next period directly 80. Fine, 8 table 8 is 64. If you subtract this, 16, and next two zeros. Now this 8 becomes double is 16. Now next it is 160 169 nines are. It should be same. 1521. Now we subtract this. 79. Yeah, 10 minus 1 is 9. Carry 79. Next set is 00. So 660, 169. So we need to add plus 9 for this. Units place should be added. This is 178. Now 178 4 4s are 1784 4s are. That is 7136. So whatever the remainder, now we got only 3 places. Therefore answer is 0.894. So here third place is 4. It is less than 5. Since less than 5, we can remove this. So 0.89 itself is answer. Now it's less than 5 means you can remove. So 0.89 is a square root of 0.8. So correct up to 2 places of decimal. If it is a integer or natural number, if they'll give one more example. For example, find the square root of 3 correct to 2 places of decimal. Correct to 2 places of decimal. So root 3. That means you can take 3.000. So 3.1, 2, 3 sets. So 3 period we need. That means 6 zeros. Okay, 2 set. Now 3 is only 1. Now this is 1 1's a 1 because 2 2's are 4. It's more than that. 2 is number. Whenever I'll take the digits period after point, you keep the point. 1 becomes 2. Then 27 sevens are. Okay, there is 189. If you subtract, it's 11. Next set is 2 zeros, 1100. So 27, right? This 7 should add to 27. Now that is 34. So this 7 place should be added again. One more 7. 27 is 34. Now next to 34 we have. So 343 3s are. Same number. 1029. Subtract 71. Next to 2 zeros if we take. Now 343 becomes 346. Okay, 3 becomes double is 6. Therefore 3462 twos are. Same number. So is approximately 6924. So any whatever remainder, now this is the value. So square root of 3 is equals to 1.732. So third place is less than 5. That means that we can neglect. Because less than 5 we can neglect it. So square root of 3 is equals to 1.73. So this is the way we can find out the square root of numbers which are not perfect squares, at the same time which are decimal numbers also. How many places we need, that many places we need to find out. Up to which place we require extra one more place you have to find out, then we need to round off that. Now we'll see how to find the square roots of fractions. In square root of fractions, for any positive real numbers a and b, so let us take a, b. These two are the positive real numbers. Then we can write square root of a into b is nothing but square root of a into square root of b. You know it. So similarly, square root of a by b. square root of a by b is equal to square root of a divided by square root of b. So we can write. Now using these two formulas properties, we can find out the square root of the fractions. So a and b are any two real positive integers. They ask the question, find the square root of 441 by 1849. So we need to find out the square root of this. So according to root a by b is equal to root a by root b. Now we can split separately. That is square root of 441 by and square root of 1849. So we'll find out the separately for root 441 and 1849 by division method or prime factorization method, and we'll simplify this solution. So 441. So division method I am applying now. As we have discussed, 41 4. So 2 2s are 4. Subtracting the remaining period is 41. Now 2 becomes 4, then 41 ones are is 41. So we are 21. So square root of 441 is 21. Square root of 441 is 21 by, similarly square root of 1849. So we can use 1849, 1849. So using division method, now 18 is near to perfect square is 4, because 4 4s are 16. 4 4s are 16. Subtract 2. Next 49 you take down. So 4 if you double is 8. Then this is near to 83 3s are. Okay, 83 3s are 249. Now that is 43. So 21 by 43 is the square root of 441 by 1849. Fine, we can find out, we can split using the formula, and we can find out separately square roots, then we can simplify the solution. Similarly, I give one more example. Find the value of square root of 21 21. So this is a mixed fraction, 21 2797 by 3364. So to evaluate this, first mixed fraction will convert into improper fraction. So if you convert this into, you get 73,441 by, because this is 3364. So 3364 into 21. So we know how to convert, right? This both will multiply and we'll add 2797. 2797 will add. Then we'll get 73,441 by same 3364. Then we have to do the square root separately. Square root of 73,441 by square root of 33,364. So by using division method, if you apply, we'll get the answer. This is 271 because 271 is a square root by 58. Again convert into mixed fraction by doing division. 439 by 58. Okay, this is the way we can do even square roots for the fractions also. So by using these two properties. So similar informations are available in the website. So you can go through it. You can download all the model papers, question paper from this chapter, including other subjects also is available. So I hope you understood well. Thank you for watching and subscribe to the channel. We will upload all the videos which are related to the educational and helpful for the students.